difference interpolation formula, Newton forward difference interpolation formula here. The function y is f of x, take the value y0, y1, y2, and so on, yn. In the point x0, x1, x2, x3, and so on, xn, and the values will be equally spaced x0 plus ih, i0, 1 to n, where h be the interval of difference. Let phi of x be interpolating polynomial of nth degree and taking same values as y at the point x0, x1, x2, and so on, xn. So see here, let phi of x represent y equal to f of x, so that phi of x is identified at the terminal points x0, x1, x2, and so on, xn. Then the polynomial phi of x can be written in the form of phi of x a0 plus a1, x1, and x0. And what we have seen here, x minus x0, x minus x0, x minus x1. In the second condition, this is the third condition we are taking, x minus x0, x minus x1, x minus x2, plus a and x minus x0, x minus x1, x minus x2, and xn minus 1. By the definition of interpolating polynomial, we are taking here phi of xy is equal to y, phi of x1 is equal to y1, phi of xn is equal to yn. So therefore, I am substituting these values here, x0, x1, x2, xn represented respectively in equation using conditions f of x0, phi of xy, x0, a0, a0, y0 is equal to a0, a0 equal to y0, f of x1, phi of x1 is equal to a1 plus x1 minus x0. So what I am taking here, the values of this one, just a minute. So phi of a0 is equal to y0, phi of x1 a0 plus a1 x1 minus x0, a0 plus a1h. So therefore y1 is equal to y0 plus a1h, a1 is equal to 1 by h, y1 minus y0 delta y0 by h. So therefore a1 is equal to delta y0 by 1 factorial by h, 1 factorial by h. So you have to find phi of x2 is equal to a0 plus a1 x2 minus x0 plus a2 x2 minus x0, x2 minus x1 plus a0 x, a1 into 2h plus a2 into 2h into h we are taking here only. And also y2 is equal to y0 plus 2 1 by y0 plus a2 2h square, a2 is equal to 1 by 2h square, y2 minus 2 by 1 plus y0 delta square y0 by 2 factor by h square we are taking here. So y2 y0 plus 2 into y1 minus y0 plus 8 out 2h square, a2 is equal to 1 by 2h square, y2 minus 2. Okay, del square y0 by 2 factorial h square. Similarly we get here delta cube y0 by 3 factorial h cube, therefore delta 4 y0 by 4 factorial h square 4, del power n y0 by n factorial h power n. Substituting these values a0, a1, a2, and so on, an. So f of phi of x to y is 0 plus x minus x0 del y0 by 1 factorial h plus x minus x0 x minus x1 del square by y0 by 2 factorial h square plus x minus x0 x minus x1 x minus x2 and so on, x minus xn minus 1 del power n y0 by n factorial hn. So these Newton's forward difference interpolation formula y is equal to f of x, then the function f phi of x can be written as u is equal to x minus x0 by h. So x is equal to x0 plus uh, then phi of x is equal to phi of x0 plus uh. So therefore yu is equal to phi of x0 plus uh is equal to what we are taking here, y0 of 1 u by 1 factorial of delta y0, u into u minus 1 by 2 factor of del square y0, u into u minus 1 u minus 2 by del cube y0, and so on into u minus 1 and u minus 2 u minus and so on u minus n minus 1 by n factorial del power n y0 we are taking here. And this formula is Newton's or Gregory forward difference interpolation formula. So given the difference del y0, del square y0, and del power n y0. So we assume f of x approximately a polynomial phi of x degree less than or equal to n. All the forward difference phi of x order greater than n at any point x0. So yu is equal to 1 plus u by 1 factorial delta u into u minus 1 by 2 factorial delta square u into u minus 1 u minus 2 and u into u minus 1 delta cube into u minus 1 u minus 2 u minus 3 by 4 factorial delta of. If numerator we are taking 3, so by factorial 4 factorial del power 4. So therefore Newton's forward difference interpolation logic is used to interpolate the value of I squared f of x near the beginning of the set of tabulated values are exploring the values y equal to f of x corresponding to the value of which lie before at the left of the table here. So suppose one table we are taking here, obtain the Newton forward difference interpolating polynomial. We are taking here 1.5. So 1.40, 1.56, 1.76 to 2.28. So see here, I am minusing this one 1.56 minus 1.40 is 0.16, 1.76 minus 1.56 that is 0.20, 2 minus 1.76 is 0.24, 2.28 that is 0.28. So 0.20 minus 0.20 means 0.6, 0.4, 0.24 minus 0.20, 0.4, 2824 that is 0.4, 0.4 minus 0.40. What we have to table of down value to up value, down to up value. See here these two values, then these two values, then these two values we are minusing. This is del y naught, this is del y1, this is del y2, this is del y3, this is del square y naught, this is del square y1, this is del square y2, del cube y naught, del cube y1, this is del 4 y naught. So first y naught, then y1, y2. We are taking the values as per this one. So then, so here we have x naught is equal to 0.1, x equal to 0.1. So therefore we are taking the value of del y naught is equal to 0.16, del square y naught is equal to 0.04, 0.04, del y naught is equal to also 0.4, 0.60, 1.4 first one, then 0.60, 0.4, and 0, del cube y naught, del 4 y naught is 0. So these values I am substituting in the equation y naught plus x minus x naught by del y naught by 1 factorial x minus x naught, x minus x1 by del square y naught by 2 factorial square, plus x minus x naught, x minus x1, x minus x naught, del cube by y naught 3 factorial x cube. So therefore 1.40, this way I am applying the value, then 0.01 by 0.06 by 1 by 0.1, x minus 0.1, x minus 0 by 0.04 by 2 factorial 0.1 whole square, 1.40, x minus 0.1, 1.6, x minus 0.1, x minus. So I'm simplifying this one. If I'm simplifying the equation, I'm writing the value. So I'm multiplying 1.6 into x, that is 1.6, minus 1.6, then 2 into x square, 2x square, that is 0.4, that is 2x square plus x plus 1.28 I am taking here. Just wait. So see here, this one example is 0, 1, 2, 3, 4, 1, 3, 9, 27, 87. See here. So 0, 1, 2, 3, 4, 1, 3, 9, 27, 87. Since the value of x equal to 0.5 at the beginning of the tabular values, use the Newtons of the forward difference interpolation formula we are taking here. So f of x naught plus h, y naught plus u by 1 factorial of del y naught, and u into u minus 1 2 factorial by del square y naught. U into u minus 1 u minus 2 3 factorial. Del 3 y naught, u is equal to x minus x naught. So therefore, I am taking this is the value of 0.5 and 0 by 1 by 0.51. So 0.51. So now we construct the forward difference table for the following data 0, 1, 2, 3, 4. So 0, 1, 3, 139, 27, 81. So we are taking 139, 27, 81 and taking here. So 3 minus 1, 2, 9 minus 3, 6, 27 minus 18, 81 minus 27, that is 54. 6 minus 2, 4, 18 minus 6, 12, 54 minus 18, 36, 12 minus 4, 8, 36 minus 12, 24, 24 minus 8, 16 we are taking here only. Then from the table we are taking here. So 1 minus 3, what we are taking to here, 1 minus 3, 2, 3 minus 1, 2, 9 minus 3, 6, 27 minus 18, 81 minus 21, 54, 6 minus 2, 4, and 18 minus 6, 12, 54 minus 36, 12 minus 4, 18, 36 minus 12, 24, 24. This is the values what we have came here. So see here, then del y0 is equal to del y del 2, del square y naught 4, y0 4, del cube y naught 8, del 4 y naught is equal to 16. Substituting these values in the formula 0.5, 1 plus 0.5 plus 2 into 0.5, 0.5 minus 1, 2 factorial, 0.5, 0.5 minus 1, 0.5 minus 2, 0.5 means I am taking 1 by 2 here. See here, all of you, I am taking here 1 plus 1 by 2 minus 1, that is 1 by 2 into 2, 1 by 2 into 1 by 2 minus 1 into 4 by 2, 1 by 2 minus 1 by 2 minus 1 by 2 minus 3 by 2. So then 1 by 2, 1 by 2 minus 1 by minus 1 by 2, this is 1 by 2 minus 2 minus 3 by 2. This 8 by 3 factorial minus 8 by 6, this is 1 by 2, 1 by 2 minus 1 minus 1 by 2, minus 3 by 2, minus 5 by 2, 16 by 4 factorial minus 24. See here, 1 by 2 to get cancelled here, with 1 plus 1. 2 into 2, 4 cancel, minus 1 by 2. Then the 4, 4 2 cancel. If there is plus 3 by 6 and 1 by 2, this is also plus 1 by 3, 1 by 3, 2. Then minus into minus, minus here. So you have to check here what is the value. So then now these all get cancelled here. 16, 3, 1, 3, 8 that is minus 5 by 8. So 1 plus 1, 2 plus minus cancel here. 2 minus 5 by 8, 11 by 8. So there is called 1.375. What is the output value came here? So in the tabular data, given the data, if I equal f of x are missing, we can find these values. So they illustrated the following: 1, 2, 2, 5, 3, 7, 4, 5, 32. Y0 is equal to y1 is equal to 5, y3 is equal to value we don't know, y3, y0. See here, y1 is equal to 5, y2, y3 we don't know, y4 22. Y0 to starting here the values. So what is the fundamental formula here? Delta cube f of x is equal to delta 4 by 4 f of x. So e minus 1 whole power 4 y naught is equal to 0. E power 4 minus 4 e cube plus 6 e square minus 4 e plus 1. So e power 4 means that is y naught. I am multiplying here. It's 4e cube y naught, 6e square y naught minus 4e y naught plus y naught. So therefore y4 means what is that value? We know that y4 here. This is y4 here. What is 32? 32 here. Then we don't know value y3. Then 6 into 7. Then 6 into 7. Then 4 into 5. Then 2 into 4 into 5. Then 2. We are multiplying here. 4 minus 4y3 come left here. 32 plus 42. 7 into 6 42. 4 into 5 20. 32 40. 72, so 74 minus 20, 76 minus 20, 56 by 4 is equal to 14. The values of output come here. Then Newton's backward difference formula. So then Newton's backward difference interpolation formula we are taking here. In the Newton backward difference and backward difference interpolation formula, we know that Newton forward difference interpolation formula is not generally used for interpolating the values for the values for this purpose. We use of the other formula known as Newton backward difference interpolation formula. Let the function y is equal to f of x, the value y0, y1, y2, y3, and so on, yn at the point x0, x1, x2, and so on, xn, add the values of x equally specified. Space x0, i plus h, I is equal to 0, 1, 2, n, which are intervaling differences. With phi of x interpolating polynomial density, the x is also the same values x0, x1, x2, and so on, xn. Then the polynomial phi of x can be written in the form of a0 plus a1 x minus xn, a2 x minus xn, x minus xn minus 1, a3 x minus xn, x minus xn minus 1, x minus xn minus 2, a4 x minus xn, xn minus xn minus 1, x minus xn minus 2, x minus xn, xn 3. So we are taking by the definition of the interpolated polynomial. Phi of xn, yn, phi of xn minus 1, yn minus 1, phi of x is equal to 0. So substituting xn, xn minus 1, xn, x1, x0 respectively in the equation. Using conditions, we get f of xn, phi of xn equal to a0, yn equal to a0, a0, yn. For f of xn minus 1, phi of xn minus 1, a0 plus a1 xn minus 1, xn, a0 plus a1 minus h. So therefore, yn minus 1, yn is equal to yn minus a1h. A1 is equal to 1 by h, yn minus 1, that is, we are taking this, the nabla yn by h is equal to nabla yn by 1 factorial of h. F of x into n minus 2, phi of xn minus 2, a0 plus a1 xn minus 2 minus xn plus a2 xn minus 2 minus xn, a xn minus 2 minus xn minus 1, that is, we are taking a0 plus a1 minus 2h plus a2 minus 2h minus h we are taking here. Then a to 1 by 2h square, yn minus 2n, 2 yn minus 1 plus yn minus 2, nabla square yn 2 factorial by h square. Similarly, we get a3 nabla 3 yn 3 factorial by h cube, a4 nabla 4 yn by 4 factorial h power 4, and so on, an nabla n yn by n factorial hn. Substituting these values a0, a1, a2, a3, a4, an in the equation, f of x f of x n minus 1 nabla square by n by 2 factorial of h2 we are taking here. Then nabla then x minus xn, xn minus xn minus 1. So we are taking the values of this one the same here. So therefore x minus xn, x minus xn minus 1, and so on x minus x1, nabla in x by n by n factorial of hn. Equation 3 known as a Newton and backward difference interpolation formula we are taking here. So since phi of x is the interpolation of polynomial, y is equal to f of x is the function phi of x can be written as determinant u is equal to x minus xn by h. So we x is equal to xn plus uh by f of x is phi of x plus phi of xn plus uh. The equation can be written as phi xn plus that is yn plus u by 1 factorial of the nabla yn into u plus 1 by 2 factorial nabla square yn into u plus 1 u plus 2 3 factorial by nabla by n and so on into u plus 1 u plus 2 and so on u of plus n minus 1 by n factorial nabla n by over n we are taking here. So this is the formula called Newton's or Newton Gregory backward difference interpolation formula with the rest return is in the backward differentiation we are taking here. Example, so in the tabulated formula, given the following table values here, so we are taking the values here 1, 1, 1, 2, 8, 3, 27, 4, 64, 5, 1, 25, 6, 2, 1, 6, 7, 3, 4, 3, 8, 5, 2. So this is the values of the 7.5 they are asked here. Of 7.5 I'm taking here highest value is 8. So 7.5 minus 8 that means 0.5 by 1. So that is also we are taking minus 1 by 2 that is minus 0.5. So we are taking they are asked 7.5 here they are asked 7.5. 7.5. So that's why I'm taking here only here. I'm taking here. So x minus xn by hx. So therefore I'm taking the values 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 8, 26, 400, 5, 1, 12. So this is a delta nabla value I'm taking here. 8 minus 1, 7, 27 minus 8, 19, 64, 27, 37, 125, 64, 61, 216, 125, 91, 5, 3, 5, 43, 216, 127, 5, 12, 3, 43, 169. 19 minus 12, 12, 37 rupees 18, 61, 61 minus 37, 24, 91 minus 16, 30, 127 minus 91, 36, 116, 27, 40. All our sixes here 18 minus 12, 6, 24 minus 6, 30 minus 24, 6, 36 minus 6, 42 minus 6. All the zeros are comparing here only. Then we are taking here. For the table of this value, I'm taking here 5 to now the delta means we are taking del by 0, del by 1, del by 2. So del by 0, del square by 1, del 2 by 1, del 4 by 1, we are taking the first class. But in the nabla, we are taking the lowest, in the down values, these values are we are taking here. So then 5 to 12, then 160 and 42, 6 zeros, all zeros here. So I'm applying these values here. So f of 7.5 plus 5 to 12 minus 0.5 of 169, then 0.5 of 5 minus 1 plus 1, then 6, then all zeros, the remaining values are zeros. So we did not write here zeros, so automatically zeros here. So therefore f of 7.5 421.875. The population of town in the decimal census of the following table. So 1951 46, this is the values that we given here. So x is equal to 1985. So the problem they given here, that's 1985. So therefore, f of x1 plus h y n by 1 factorial and then nabla y n u plus 1 by 2 factorial nabla square y n u plus 1 u plus 2 by 3 factorial nabla by n. I am taking here. So see here, u into x minus x naught and by h x n is equal to 1991. 1991 I am taking the highest value. There is a total interval 51, 61, 71. There is interval is 10. So f of x is equal to 1985 minus 1991. 1985 for the given what is the finding the value 1985, 1991 we are taking the values here. So that is minus 6 by 10.6. So we shall now construct the backward difference table to the given data. 1950, 1951, 61, 71, 81, 91. So therefore 46, 60, 46, 66, 81, 93, 101 we are taking here. So with that is again we are taking here 66 to 46, 20. 81 lagi berarti 15, 93 berarti 12, 101 lagi berarti 8, 15 lagi 20 berarti minus 5, 12 lagi berarti minus 3, 8 lagi berarti minus 4, minus 3 plus 5 plus 2, minus 4 plus 3 minus 1, minus 1 minus 2, minus 3, 0 power, it not should be 0, mandatory, the values we have to find out. So nabla for y now, y 101, nabla 1, y8, nabla y square, yn, minus 4, this is minus 1, this is nabla 4, that is minus 3. F of 198, 1985, that is we are writing 101 plus 0.6 into 0.8, minus 0.6 plus 1 by minus 4, 0.6, 0.6 plus 0.6 plus 2. I'm applying these values of the, what is the 0.6? This is the u into u plus 1, u into u plus 1 and u plus 2. I'm applying the values here. And automatically, that is 101 minus 4.8 plus 0.48, that is 96.8. 368, that is approximately we are taking here. Then find the cubic polynomial which is the fixed following the data, hence or otherwise find for 0, 1, 0, 0, 1, 1, 0, 2, 1, 3, 0. We first construct the forward difference table, the given data. 0, 1, 2, 3, 1, 0, 1, 0, 1, 0, 1, 1, 10. So 0 minus 1, 0 minus 1 minus 1, 1, 0, 1, 10 minus 1. 1 plus 1 this is 2, 9 plus 1, 8. 8 minus 2, 6. So we are taking the concept in the table here. Only this is one value, there is no for, there is no therefore. But because there is no minus is there, so we can get the table of the value of the only one we are taking here. X naught is equal to 0, x is equal to 1, y naught is equal to 1, del y naught is equal to minus 1, del square is equal to 2, del y is equal to 6. So this is a Newton forward difference interpolation formula. Y naught is y naught x plus x naught, del y naught by 1 factorial x minus x naught, x2 minus x minus x naught by del square y naught by 2 factorial x square, x minus x naught, x minus x1, x minus x2, del cube by y naught 3 factorial by h cube. So del cube by 3 factor h cube. So f of x 1 plus x minus 0 minus 1 by 1 by x minus x naught. So therefore, uh, so I am applying the values here, x minus x minus x naught, 2 by 2 and x minus x naught, x minus 6 by 6.1 we are taking here. So therefore, I am applying 1 minus x, then x into x minus 1, then x into x minus 1. This is cancel the values of x into x minus 1 and x minus 2. We are taking here only. So therefore, 1 minus x minus 1 minus x plus x square, 1 minus 1 minus 1 minus 1. 1 minus x is 1 minus x plus x square minus x plus x2 minus x square minus 2 plus x. So we are taking here, just a minute, and alternative we can compute f4 also, we can compute here. So therefore, we are taking here this compute as follows here. F4 yn plus u del lambda yn, u will be plus 1 to factor lambda square yn. So u is equal to x minus xn by h. So therefore, So for you x minus x is equal to 1, you have to find the value of x is equal to 4. X is equal to 4 minus 3 by 4 minus 4 minus 3 by 1 is equal to 1. So we are taking the values of that. You are taking the values of that one. So y is equal to 10. Then nabla y is 9, 8, yeah, and the nabla of 2 yn is equal to also 6. 10 plus 9. So 1 plus 1 plus 1 by 2. 1 into 1 plus 1 plus 2 by 6. That is the total 33 we are taking here. Then another example, we are taking the best week. The values of 0.10 less than or equal to x less than or equal to 0.30 are given in the following table on interval of using this one tan 0.1, tan 0.6. We are taking tan. So see here 1.0100, 0.1511, 0.2027, 0.2553, 0.309. So I am taking here 2.3093 I am taking here. So this one 0.508. This one I am removing here 0.516. This one I am removing this 0.0526. This one removing 0.050. And this one removing 0.008. This one removing 0.0010. And this one, and I am taking the lowest value to highest value I am taking here. So this one I am taking here. So 0.008, 0.0010, 0.0014. So therefore 0.0018 to 0.0022, 0.0014 to 0.0044. And these two values we are taking as 0.00202. That's the value is the output we are taking here. So therefore what I am taking here, 0.516, 0.508, 526 local 516 to 0.10, 540 5 with 0.4, 0.10 local 0.8 with 0.2, 0.10 5 with 0.4, 0.4 local 0.2 with 0.2 గా మనం రాసుకోవడం జరుగుతుంది. సో అదేవిధంగా so since the x is equal to 0.1 is the near beginning the tabular values we are taking here. So f of x naught plus h y naught u by 1 factorial delta y naught u plus u into u minus 1 by 2 factorial delta square y naught I am taking here. That is u is equal to x minus x naught by h. So x naught is equal to 0.10, h is equal to 0.05. I am taking here 0.112 minus 0.112 minus and 0.02 here. So 0.12 minus 0.10. What is the tabular value I am taking here? 0.10 minus in here. So there is 0.4. I am applying these values in the from the table x naught 0.10, x is equal to 0.5, tan 0.10, 0.1003, 0.4, 0.058. All these values I'm applying, so therefore 0.1207 the output came here. Since the x is equal to 0.26, so the near end that value is 0.26, the Newton backward difference formula, xn plus uh yn, u plus nabla yn, u into u plus 1 by 2 factorial nabla square yn, u into x minus xn by h, we are taking here 0.26 minus 0.30 by 6.5. From the table, yn is equal to 0.3093, nabla yn is equal to 0.0540, nabla square by 0.0014, nabla p by 0.0004, nabla 4 by 0.0002. Substituting these values in the formula, we are taking here 0. So yn is equal to 0.3093. But nabla yn 0.0540, nabla square by 0.0014, nabla cube by 0.2204, nabla 4 by 0.2202. All these values I am substituting here. So therefore automatically tan 2.6 also there. Then also same values in the how is 0.3093 tan 0 minus 0. I'm applying and the calculate the values here are the same as the coming here. Tomorrow's class we have sub tabulation what we will do. Any doubts, ask me. In subtabulation, we are doing here very often to require in subtabulation. X is equal to 0 to 530 will be necessary and complete 0 into 36 interpolation. Y of x of 1 plus nabla whole power x into y naught become the outlines we are taking here. In practice, one usually needs to be subtabulate the final subdivision 1 by 2, 1 by 5, 1 by 10. We are taking here by the length of the original division. We note that the however required is general. So suppose we are asked to here tablet y is equal to cos x and x is equal to 31 into 50. The composition involved in interpolated y of x is equal to y of x plus h minus y by x. We are writing it. We can learn in the tomorrow's class and the problems in the next class. Thank you.